Okay, let's go. Alright, what I'll do first is place the problems on the board. Because we are just going to do the classwork for simultaneous equation. We have problem number 1. X plus 3y is equal to 7 and 2x minus 2y is equal to 6. So that's your equation 1 and that is your equation 2. Now, it's quite a bit and I hope that you will bear out with me until closer to 8:30. Well, we have half an hour till 8 o'clock, but all that I need to demonstrate to you, because I'm going to take more than one takes on this problem that we have on the board at the moment. Alright, since we're going to take more than one takes, I'm going to put another one up there. The same thing. X plus 3y is equal to 7. 2x minus 2y is equal to 6. And I'm going to take a look to see how far I will go into the glare and try to put another one there. X plus 3y is equal to 7 and 2x minus 2y is equal to 6. There we go. Alright, so good evening everyone. We are about to start the classwork that I intended to start at 6 o'clock. Believe me, everywhere you turn, traffic. And as a matter of fact, for some of the individuals living in the environs of Montego Bay, they are walking home. That is how bad it is. However, I'm going to try to see how much of these I'll be able to get through tonight. I'm just looking at maybe 6 problems. But for this one, I'm looking at it from 3 different perspectives. So let us begin with number 1. As a matter of fact, I'm taking it from the homework section, so you do not imagine that I will do every single one of them. I will only do the odd numbers, and you continue to do the even numbers for your homework. All right, so let's begin. We have this pair of simultaneous equation. We have x plus 3y is equal to 7 and 2x minus 2y is equal to 6. An individual might want to take the problem and seeing a 2x here, if you just multiply this by 2, you will have 2x also. So we have 2x here, and if you multiply by 2 here, we will have 2x. So we have 2x and 2x, and then the equations will be ready for the elimination of x. So let's go. We'll take equation 1, and we multiply it by 2, and we get 2x plus 6y is equal to 14, and that is our equation 3. Notice now that we have 2x here and 2x here, we are ready to eliminate. Now, since they are identical, they are not additive inverses. Since they are identical, we will eliminate the x's by subtraction. So we may say equation 2 minus equation 3 or equation 3 minus equation 2. But realizing that equation 3 has the larger numbers, if we say 3 minus 2, we stand a chance of having more positive values in the equation. So let us say then, equation 3 minus equation 2. What happens now? 2x minus 2x, that's gone. 6y minus negative 2y. And then we'll say 14 minus 6, and that's 8. So I'm going to put this under the 2. It is not 6y minus 2y. It is 6y minus negative 2y. And because of that, let us do it in 2 steps. 6y plus 2y, and that is equal to 8y. So what we have here is 8y is equal to 8, and everyone can see what y is equal to in a second. I'm going to put it over here. Y is equal to 8y is equal to, yes, 8y is equal to 8. 8 times something, and the result is 8. That something has to be 1. Now that we have found the value of y to be 1, we will place that into one of the equations. I'm going to put that into equation 1 because equation 1 seems to be the simplest of all. So let's go. In equation 1, where we see y, we put 1. So we begin by writing x. X plus 3 times, x plus 3 times, and y, so x plus 3y, y is 1. And that is equal to 7. So x is equal to 7 minus, of course, we are adding, of course, 3 ones 3, and we are adding 3. So we'll eliminate that 3 by subtraction. So x is equal to 4. And I always instruct my students not to leave the system solved. Although it is solved and you have all of the answers and they are right, do not leave it like that. Don't cause the person who is marking your paper to look inside of your solution to find the answer. Let the answers just be blatant in their face that they cannot avoid it. So we'll write finally x is equal to 4 and y is equal to 1. Let's continue. Now, what do we do with this take? It is the same system of equations. Yes, it's the same system of equations. Although it will take the student longer, or we say the candidate longer. Yes, although it will take the candidate longer, some candidate will not miss the opportunity to make additive inverses out of these. So, because of the desire to have additive inverses, the students will go straight ahead, attempting to eliminate the y's instead. So, eliminating the y, that's our target, we'll take equation 1 and we'll multiply, a little bit closer, equation 1, and we'll multiply equation 1 by 2. So the number here will multiply the equation there. So equation 1 multiplied by 2, and what do we get? We get, multiplied by 2, 2x plus 6y is equal to 14, and that is equation 3. Then, the student will go further to take equation 2, which is the equation right here, and multiply by 3. Of course, you realize immediately that this solution is poised to be longer. But so doing, you have what? Equation 2, and we're going to multiply that by 3. We'll have 6x, here again, minus 6y is equal to not 36. We need to multiply the 6 by 3 also, and that will give us 18. And that is equation 4. Yes, so that's what we have. Now that we have the additive inverses, which will eliminate each other by addition, we will add the two equations. Do not forget, which is equation 3 and equation 4. The additive inverses will have a cancelling effect on each other by addition. So let's add. So when we add, what do we get? 2x plus 6x, and that is 8x. The y's are gone, being additive inverses. And what do we get? 14 plus 18, that is 32. And of course, x is equal to 1 again. And we may want to put that into equation 1 again. When we put that into equation 1, we may solve by analogy, because this is the same thing that we have over here from here on. So we continue by analogy. It is the same thing. So x is equal to 1. When we put this into the equation 1, we get the same thing. X plus 3 times 1 is equal to 7. X is equal to 7 minus 3. X is equal to 4. Then we say what? X is equal to 4. Y is equal to, I hope it's not 3, 1. So the student would have taken advantage of the additive inverses here. And over here, the student would have taken advantage of how easily we just multiply one of these equations by 2, and we're on. But this student need to differ. So in this case, what will the student do? The student will take equation 1, not equation 1. Let me do that again. The student will take equation 2. The student will take equation 2 and divide it by 2. So the student takes equation 2 and divide it by 2. Now this problem lends itself to simplicity if we divide by 2. Because all of the numbers are multiples of 2, and we will not have any, what will we have? We will not have any fractions. So we'll have no fraction. So we have x, we're dividing this by 2. 2x divided by 2 is x. Then 2y divided by 2 is y. Then 6 divided by 2 is 3, and that is your equation 3. Now, do not forget that we have manipulated equation 2 here. So equation 2 is the one that we are using. So equation 2 is out of it. So the equations that are left in the system will be equation 1 and equation 3. And notice that we do not have additive inverses anymore. The x's are exactly the same. They are identical. Because they are identical, we will subtract. We only add when we have additive inverses. So let us subtract. Do we say equation 1 minus equation 3, or equation 3 minus equation 1? So that's a lovely question. All of the time, what I do is I look for the one with the larger numbers and subtract the smaller one from that one. And that is so that I do not get negative values. So we have equation 1 minus equation 3. We can take a little bit more liberty right here. Not worrying about this space, since one of the unknowns will be eliminated. Equation 1 minus equation 3. And what do we have? Of course, the x's will be eliminated. Then we have 3y, not minus y. 3y minus negative y. So we have 3y minus negative y, which is equal to 3y plus y, which is equal to 4y. So 3y minus negative y is 4y. Equation 1 minus equation 3. We get what? 4y is equal to 7 minus 3, which is equal to 1. Is that what we get? 7 minus 3. I'm looking at the screen. No, no one is going to say that's not right. So it is 7 minus 3, which is 4. So y is equal to 1, and we are going to put that into equation 1. And what do we say? We say what? Let me see if there's anybody who is saying something is wrong there. Good night again. There's no one saying that something is wrong right there? Come on, students. Let's continue nonetheless. So what do we have? We put that into equation and we have x plus 3 times 1 is equal to 7. So x is equal to 7 minus 3. So x is equal to 4. Nothing on the board? Alright, let's go. So x is equal to 4 and y is equal to 1. Let's go back to that. 8x is equal to 32. Let's go back to it. 8x is equal to 32. Obviously, x is equal to 4. 8x is equal to 32. X is equal to 4. We're going to still put that into equation 1. Into equation 1. When we put that into equation 1, what do we have? 4 plus 3y is equal to 7. X is equal to 4. So where we see x, we put 4. 4 plus 3y is equal to 7. So 3y is equal to, we're going to eliminate this 4 by subtraction. 7 minus 4 is 3. And then y is equal to 1. Then we say x is equal to 4 when y is equal to 1. Come on, students, you should not allow me to go so far with this one. So for number 1, I solve it 3 different ways. Now I'm going to erase number 1 very quickly, but let's see what we make of number 3. And I'm going to use I'm going to put that below the glare. Right, so I think that I can put number 3 right here. The first take of number 3 will go right there. Two x minus y is equal to 1. 2x minus y is equal to 1, and that is equation 1. Maybe I should have dressed it over a little bit more. Two x minus y is equal to 1, and that is equation 1. We have what? Negative 2x plus 3y, and that is equal to negative 2x. 2 plus 3 is equal to 5, and that is equation 2. So we have 2x minus y. 2x minus y is equal to 1, that's equation 1. And negative 2x plus 3y is equal to 5, and that is equation 2. I hope that no one is alarmed that I placed it in that small space. Right, I'm placing it in that small space because I know that we should be able to solve it right there. Why is that so? It is so because we already have additive inverses here. A 2x and a negative 2x. So the x's are ready to be eliminated. So we may go straight ahead and eliminate the x's. They are additive inverses. Additive inverses have a cancelling effect on each other by addition. Equation 1 plus equation 2. Because these are additive inverses, by addition, they will eliminate each other. So the x's are gone. Then what do we have? A negative y with a positive 3y. Yes. Many students imagine that I was overdoing it. I was overzealous. It is because I am presenting the mathematics to the students why I'm emphasizing, re-emphasizing, overemphasizing the importance of your ability to manipulate directed numbers. But now you are seeing it for yourself. If you fall short of that, you're not going to get the right answer. Let's go. When we add a negative y with a positive 3y, we get 2y. 2y is equal to 1 plus 5 is equal to 6. So y is equal to 3, and I'm going to put that into equation 1. Y is equal to 3, and I'm going to put that in equation 1. Put that into equation 1. What do we have? Where we see y, we put 3. So 2x minus 3 is equal to 1. 2x minus y is equal to 1. 2x minus y is equal to 1. Y is 3. So 2x minus 3 is equal to 1. And you surely can see this because we solve a lot of linear equations. That 2x is equal to 4. And then x is equal to 2 because what? We solve a lot of linear equations. So what do we say now? Finish up. X is equal to 2 while y is equal to 3. So we have 3 takes for problem number 1. We did, and I'm going to do a second take for problem number 3. Yes, I'm going to approach it another way. It's quite lovely. Problem number 3 again. What do we say about number 3? 2x minus y is equal to 1. Negative 2x plus 3y is equal to 5. And that is your equation 1. And that is your equation 2. Well, we have additive inverses already. And some students would be very quick to just make use of them. But let's say someone sees it like this. Equation 1 multiplied by 3. So somebody sees it like that. Equation 1 multiplied by 3. We get, take the entire equation 1 multiplied by 3. We get what? 6x minus 3y is equal to 3, and that is your equation 3. Why did I multiply equation 1 by 3? So that we have additive inverses for the y. I wouldn't do that in an equation, in an examination. I would go straight ahead and just eliminate the x's since they are already additive inverses. But let's say somebody beg to differ. There's no problem. So what we have here, notice that now we have the plus 3y and the minus 3y. So additive inverses again. Equation 2 plus equation 3. And what do we have? Negative 2x plus 6x. Make sure you see that. That is not 6 plus 2, but negative 2 plus 6. We will get what? 4x. 4x is equal to 5 plus 3, which is 8. So surely, for x is equal to 8, x is equal to 2. And we're going to put that into equation 1. X is equal to 2, and we put that into equation 1. So let's go. Go to equation 1. Where we see x, we put 2. 2 times 2 minus y is equal to 1. 2 times 2 minus y is equal to 1. That's nice. You know how to put the negative sign under control when? Immediately. So let's do that immediately. 2 2's 4 minus, let me put that here. 2 2's 4 minus 1. We are eliminating the positive 1 from this side. And in the same breath, we are eliminating the negative y from that side. So we can see that what? 3 is equal to y as an intermediate step. Y is equal to 3. And we finish up with x is equal to 2, y is equal to 3. Students, you can substitute. So the substitution part of it should not be any problem. Students, you can eliminate, which is the last thing that we did, and we did that in the last instructional class. I think it was Thursday. We took an in-depth look at the elimination process. And of course, you can solve a linear equation. As soon as you do the substitution, you are through. As soon as you do the elimination, you are through. For x is equal to 8, we have just completed solving many problems involving linear equations. So for the most part, when we have simple linear equations like what we have here, you can just look at them and tell me the answer. Number 5. What does number 5 say? I think that everyone will have a grand time with the first take on number 5. X plus 3y is equal to 12. X plus 3y is equal to 12, and that is equation 1. What else? 2x minus 3y is equal to 6. 2x minus 3y is equal to 6. That is equation 2. There you go. The person who is saying that I should do substitution equations, do you have the instructional manual? Okay, so let's go. Let's continue. Now we see that we have additive inverses right there already. Yes, we have. We have additive inverses there already. A positive 3y and a negative 3y. So we may go straight ahead and eliminate the y's because they are additive inverses. And of course, we eliminate additive inverses by adding. By adding, they have a cancelling effect on each other. So the y's will be gone, and x plus 2x is 3x. That's nice. And 12 plus 6, that's 18. And then x is equal to 18 divided by 3, which is 6. And I would want to put that into equation 1. So x is equal to 6 into equation 1. Let us put that into equation 1. Where we see equation 1, we see x, we replace that with 6. X plus 3y is equal to 12. X is 6. 6 plus 3y is equal to 12. Of course, we will eliminate the 6 by subtraction. Then we eliminate the 3 by division. We are finished with that already. So x is equal to 6, y is equal to 2. That's a very nice take for number 5. We are not going to do any more takes on number 5. We will move to number 7. Oh, no. We have another take. We are going to do another take on number 5. We're going to do another take on number 5. Let's go. X plus 3y is equal to 12, and that is your equation 1. 2x minus 3y is equal to 6, and that is equation 2. Right. Of course, we can do another take on it. All we need to do is multiply this, get a 2 here. We have a 2x there. Let's get a 2 here just by multiplying this equation by 2. So equation 1 multiplied by 2, and what do we have? Equation 1 multiplied by 2, what do we have? 2x plus 6y, 2x plus 6y is equal to 24, and that's equation 3. Right. 2x plus 6y is equal to 24. That's equation 3. Now, what do we have? We do not have additive inverses. As a matter of fact, they are identical, so we will subtract. And can I say it again, students? If you do not manipulate your directed numbers in a very efficient way, then we are always going to have difficulties. Yes. So let us go forward. We have 2x with 2x, they are identical. We will eliminate them by subtraction. Do we say equation 3 minus equation 2, or equation 2 minus equation 3? I'm always going for subtracting the smaller from the larger. So I say what? Equation 3 minus equation 2. Surely, since the x's are identical, they are eliminated. Then we have 24 minus 6, and I think that is equal to 18. Then we have what? 6, not 6 minus 3, but 6 minus negative 3. 6y minus negative 3y is equal to 6y plus 3y. So what do we have here? 9y is equal to 18, meaning that y is equal to 2. I'm going to put it over here instead. Y is equal to 2. And we're going to put that into y is equal to 2. Put that into equation 1 again. Y is equal to 2. We'll put that into equation 1. Equation 1. X goes back plus 3 times y. X plus 3 times y. Y is 2, so we replace that with a 2 there, that is equal to 12. And we can see that x is equal to 12 minus whatever 3 2's will be. So again, x is equal to 6. What do we say then? X is equal to 6, y is equal to 2. You cannot jump to substitution method so fast. No, don't jump to substitution method so quickly. Do some classwork with that method first, so the students get a good idea of it. Then you move to substitution. And when you are doing substitution, I hope that you are flexible enough in your mind, because I'm always going to be teaching you something that maybe you have never seen before unless you attend my class. You know that already. I am sure that although when you come to this class, it is regulation, some students invariably eliminate the x's and don't eliminate the y's. Some students don't pay keen attention to additive inverses when they exist to use them. Some students do not know that we can multiply only one of the equations if necessary. And sometimes you don't have to multiply any of the equations. What else is there that some students were not aware of before? I'm going to say it. Some students did not know that instead of multiplying, we can divide in order to eliminate. So there are a lot of new things. Some of you, not all of you, but some of you would have been seeing this the first time when you're solving a pair of equations. And then when you're going to do your substitution, I will still do things that some of you might be seeing for the first time. Do I have another take on question number 5? No. We go to question number 7. One of your favorites. Yeah, your favorite. I'm going to do one take right there. Okay, so that's where I'm going to put problem number 7, the first take of number 7. 2x plus 3y is equal to 1. Number 7, 2x plus 3y is equal to 1. That is equation 1. Equation 2 is what? 5x plus 3y is equal to 16. 5x plus 3y is equal to 16, and that is equation 2. Students, you see that already? That the y's are identical. So you may go straight ahead and subtract. Yes, the y's are identical. Go straight ahead and subtract. Equation 2 minus equation 1, and what do we get? Surely the y's are gone because they are identical. When we subtract them, they disappear. 5x minus 2x is 3x. And 16 minus 1 is 15. So x is equal to 5. X is equal to 5. I'm going to put that into equation 1. Surely you see that the y's are identical. When they are identical, we eliminate them by subtraction. So we'll subtract one equation from the other. Now that we put x is equal to 5 into equation 1, what do we have? Where we see x, we put 5. So 2 times x, 2 times 5. 2 times 5 plus 3y is equal to 1. So 3y is equal to 1 minus what? What is 2 times 5? 10. So 3y is equal to negative 9. Implies that y is equal to negative 3. So we finish up by saying x is equal to 5 while y is equal to negative 3. Yes, that's one take on number 7. One take on number 7. And of course, you should expect that when I do a second take on number 7, it is going to be less hilarious than that one. Yes, it's going to be less hilarious than that one. Another take on number 7. What do I say? 2x plus 3y is equal to what? 2x plus 3y is equal to 1, and that is equation 1. 3x minus, no, plus 3y is equal to what? 16. So what do we say? We're just to eliminate the x's on this occasion. If we are going to eliminate the x's on this occasion, we will multiply interchangeably. So we say equation 1, take equation 1 and multiply by the number down here, which is 3, and we get what? 6x plus 9y is equal to 3, and that's the equation 3. So equation 2, we are going to multiply that by 2, because we take the equation that is here, which is equation 1, and we multiply by this number. Then we take equation 2, this equation, and multiply by that number. That's all we have done. Multiply interchangeably, and we get what? 6x plus 6y is equal to 32. I think we're multiplying by 2. 6, 6, 32. That's nice. So let's go. Multiply this one by 3. 3, 2, 6. 3, 3 is 9. 3, 1 is 3. And let me see the equation right. 2x plus 3y is equal to 1. Then this should not be 3x. It should have been 5x. 5x. So we have to go it over. It is the same system that we have there. Let's go. Because we're doing a second take at number 7. So what do we say? Equation 1 multiplied by 5 instead. Taking the number from here. Multiply that equation. 10x plus 15y is equal to 5, and that is equation 3. So we're multiplying this one by 5. Nice. Then we take equation 2 and multiply by 2 again. What do we get? 2, 4x plus, sorry about that. Equation 2, we multiply that by 2. This is equation 2, multiply that by 2, we get 10x plus times 2, 6y times 2, 32. Equation 4. Alright. So now that we have them identical, we will subtract one equation from the other. Do we say equation 3 minus equation 4, or equation 4 minus equation 3? Any which way we subtract, one of the values will be negative. So what I will do, I will subtract so that which value is negative. I'm going to subtract in such a way that the coefficient of the unknown is positive. So I will therefore say equation 3 minus equation 4. So equation 3 minus equation 4. Of course the x's are gone. 15y minus 6y, 9y, and that is equal to 20. Let's subtract that again. Of course we have a 9y, but 5 minus 32 is not 32 minus 5. It's 5 minus 32, and that will give you negative 27. So y is equal to negative 3. Y we're going to put that into equation 1. I'm going to change my mind and put that into equation 2. We are overloaded equation 1 already. Yes, equation 1 is overloaded. So let's put that into equation 2. Let's go. This is our equation 2. And y is negative 3. So begin right here. 5x goes back plus 3 times negative 3 goes back, and that is equal to 16. So what do we have? 5x is equal to 16. Of course, we're going to have a negative 9 right here. Because we have a negative 9, we're going to eliminate that by addition. Plus 9. So 5x is equal to 25. So x is equal to 5. So what do we say? X is equal to 5 and y is equal to negative 3. The 2 takes of number 9 will go right there. So let's put in our favorite. This is a very nice set, number 9. I like this one. X minus y is equal to negative 2. X minus y is equal to negative 2. That is your equation 1. That looks too far away. X minus y is equal to negative 2. That is equation 1. Then, 3x, no, let me see. 2x plus 3y is equal to 21. 2x plus 3y is equal to 21. That's equation 2. Let me take a second look. X minus y is equal to negative 2. That's right. 2x plus 3y is equal to 21. That's right. So let's go. Some students will solve this problem not looking beyond x. Right? They wouldn't look beyond x, but I would look beyond x. The students would not look beyond x. So what? Because they don't look beyond x, they say what? Equation 1 multiplied by 2, and they have a 2x minus 2y is equal to negative 4. That's equation 3. By so doing, the x's are the same. They are identical. Because they are identical, we will eliminate them by subtraction. They are identical, so we eliminate them by subtraction. And as usual, we subtract in the direction or order in such a way that we have only positive numbers. And if we have them vice versa, negative, positive, then we subtract in such a way that the coefficient of the unknown is positive. So let's go. Equation 2 minus equation 3. We are subtracting so that the result is positive, so that the results that we have here will be positive. First of all, we have not 21 minus 4, but 21 minus negative 4. And we have done quite a few problems like that before, since we have been here. So that will give us 25. And the other one is just like it. 3y minus negative 2y. 3y minus negative 2y. So that will give us 5y. So y is equal to 5 into equation 1. I'm putting that into equation 1. Yes. Y is equal to 5, and we are placing that into equation 1. So let's go. X minus y is 5 is equal to negative 2. So x is equal to negative 2 plus 5. when we get to the simple equation, students should just zip through those because we have solved so many linear equations. So x is equal to 3. So x is equal to 3, y is equal to 5. Number 9 again. X minus y is equal to negative 2. That is your equation 1. And 2x plus 3y is equal to 21. 2x plus 3y is equal to 21. And what do I do? That's equation 2. Good night. That's nice, man. So what do we say? The second take on number 9, I will multiply equation 1 by 3. Why do I do that? I do that for simplicity. I do that in order to have what? Additive inverses. That's why I do it. Yes, I do it for additive inverses. So multiplying, we get all of this. So 3 times x is 3x, 3 times y is 3y, and 3 times negative 2 is negative 6, and that is your equation 3. Of course, the y's are additive inverses and will eliminate each other on addition. So we'll go straight ahead and add. So we just say equation 2 plus equation 3, the y's are gone, 2x plus 3x is 5x, and we're going to add 21 with a negative 6, and that is going to give us 15. So x is equal to 3, and we're going to put that again into equation 1. When you put that into equation 1, what do we get? Go right here. X is 3 minus y is equal to negative 2. So all that we do is what? Eliminate the negative 2 from this side. Eliminate the y from that side. So y is equal to 5. So x is equal to 3 with y is equal to 5. Nice. And of course, after that, the only one that is left is number 11. I'm not doing on 2 takes on this, I'm doing 2 takes on it. I'm doing 1 take. So students, since I'm doing only 1 take on number 11, could you please suggest how we will eliminate, what we will eliminate? I'm not saying that we are eliminating anything. You tell me what we will eliminate and tell me the procedure of eliminating that. So I'm putting number 11 in your arms. So number 11 will be in your arms. Let's go. Number 11. 1 take for problem number 11. How many takes? 1. 1 take for problem number 11. Just 1 take for problem number 11. Any suggestion? No suggestion? Good night. I'm saying good night to somebody who I see. Good night, and yeah. We are eliminating in number 11. Someone please, let me write it on the board. Because some students do not have the instructional manual. 5x minus 2y is equal to 31. 5x minus 2y is equal to 31. And 4x plus 3y is equal to 11. 4x plus 3y is equal to 11. So I have to take a second look at it to make sure everything is correct. 5x minus 2y is equal to 31. 4x plus 3y is equal to 11. That's it. What will we eliminate and how will we eliminate it? Let's go. Alright? Whether or not okay, so I'll go straight ahead. For one, I will use the smaller numbers eliminating the words. For two, the resulting coefficients will be additive inverses. So equation 1 multiplied by 3, 15x minus 6y is equal to 93, and that's equation 3. Then equation 2 multiplied by 2, and what do we have? 8x plus 6y is equal to 22. That's a bit. The 22 is not so large, but combining that with 93, we get what? 115. We get 115. Then we get what? 15 plus 8, that's 23. X. So 23x is equal to 115. X is equal to 5. And we're going to put that into which equation? We're going to put that into equation 1 again. Should we? No, put that into 2. Put that into equation 2, what do we get? Put that into equation 2, we have 4x. So 4 times 5 plus 3y is equal to 11. So 3y is equal to 11 minus 20. So 3y. Of course, 4 5 is 20, and we're eliminating that. We don't have to make too much of it. Right? We don't have to make too much of it because we have solved so many linear equations recently. Negative 9. So y is equal to negative 3. So x is equal to 5, y is equal to negative 3. And that's your last take. No more takes on number 11. That that was a horrible day for me with the traffic and having to travel from parish to parish. That caused me to be tired. I don't want to say exhausted. So that is your classwork for solution of simultaneous equation. Expect tutorial on this Sunday. Yes, expect that tutorial on the solution of linear equation. Sorry, simultaneous equation. Expect tutorials on that on Sunday. And let's see what else we'll do. Hopefully, we do not have the same encounter on Thursday. I don't know if it is because Christmas is coming up. But believe me, we are having some serious times right now. Now, thank you everyone for joining. The participation was not like I've been accustomed to, but I understand. You know, I had some difficulty that caused me to start somewhat late. So thank you for being here. Thank you for inviting others. Thank you for sharing the live. Thank you for liking the live. What else do I thank you for? Thank you for what? Well, thanks to the new followers of Richard James Mathematics Resources on TikTok. Thank you all for being here. The old timers who have been here from the beginning, thank you for your ever being present. Okay. So, not Tuesday, Thursday. Thursday we'll continue our instructional class. And for now, it is goodbye until Thursday. Have a restful and peaceful night. Good night.